Okay, dear students, let us do one more numerical problem. This is one of the best in engineering mechanics, and in fact very important for JEE advanced examination. Uh, Here we require a calculator to calculate, but if you are sitting for JEE advanced, then the values will be so nicely given, these values, so that you don't actually need a calculator. So let us read out the statement. A 667.5 Newton man stands in the middle of a rung, and this is a ladder. Now, what is the rung? The steps. Now, I have read on a figure. This is the same ladder. These are the steps, the horizontal steps in a ladder on which you can keep your foot or your hand to climb the ladder, to climb up the ladder or climb down. Now, and weight of the ladder is also given as 222.5 Newton as shown in figure. Assuming the end B, this end B, this is important. It rests on the corner of a wall, and a stop at A to prevent the ladder from sliding. Ladder does not slide. Stop at A to prevent the slipping. Find the reactions at point A and point B. So what I must suggest you before you watch this video and do the solutions as described, I request you to first look at the solution of 2.69. This is 2.70. Look at the solution of 2.69, where there was a similar case. But at this point, the way this ladder is leaning against the wall here, in 2.69 it was different. So that is to be understood. First watch the solution 2.69, then watch this video and compare the position of the ladder, the position of this ladder in this case in 2.70 and in 2.69 at point B in both the cases. Then we will find out the difference. Now, the weight of the ladder is acting vertically downward. It is 222.5 Newton from this point, vertically downward from the center of mass. And the man having weight 667.5 Newton is also standing at the middle of the ladder. Means both the weights are acting vertically downward from the same point, and I have the same line of action. Let W1 is the weight of the man. This is given, Newton. W2 is the weight of the ladder. This is also given in Newton. And both this as well as this, they are acting from the same point downward. So, since two vectors are in the same direction, the resultant will be just the arithmetic, the sum of the two. So, the total weight W is equal to W1 plus W2, that is this plus this, that is equal to 890 Newton acting from this point vertically downward. Now the reaction, this is to be understood. Let RA is the reaction at point A. RB is the reaction at point B. Now look, so there are three forces, RA, RB and the total weight W, the sum of the weight of the ladder and the man. Now the question is, you might be wondering, you might be asking why this RA is pointing to this side, why it is not along the ladder, right? That is to be understood. Now if you look at the diagram, no angles were given in the original diagram, so I have taken few angles like alpha, beta. At this point, the ladder is leaning against the wall at the edge, means here if you slightly draw a surface like this, then this line of action RB will be normal to this surface. Now, this line of action RB, and the weight W, when produced, they meet at this point, which I have named it as E, this point. Now, for equilibrium of three forces in a plane pointing in different directions, they must have a common point of interaction. That is what we studied in the beginning of, that is what we did in the beginning of problem set 2.5. That was the condition. So, when RB is pointing to this side and the line of action of W when produced backward meets here. So, which we can later on shift this W to this point E, and R and RB to this point, towards this side will shift. Now, so this is the common point of RB and W. So, the third force RA, instead of pointing to this side, it has to pass through the same point of concurrence. Then only the condition of equilibrium will be established, right? So that is the understanding. So let angle BAD is equal to alpha. Look at BAD is equal to alpha. Therefore, angle GBA, this is also alpha. Why? Because this dotted line and this one, they are parallel, and the ladder itself is a transversal. So if this angle is alpha, this will be alpha because alternate angle. Now, then you can find out tan alpha. So tan alpha will be now will be 3.66 tan alpha in this triangle. In this triangle, BAD, right angled at D, tan of alpha will be perpendicular BD over AD, and the value of BD is given, and the value of AD is also given. So tan alpha is BD over AD, that is perpendicular over base. If you put it in a scientific calculator and take the inverse function, your alpha comes out to be tan inverse of this, that is 63 degree 26 minute 5.82 seconds of arc. Now, since the length BD is known and length AD is known, so the distance from A to B using Pythagoras theorem will be AD square plus BD square and square root of that. So I put the values, this comes out to be 4.092 meter. Now, since AC is equal to BC, because this is given, this is the midpoint, the middle of the ladder. Therefore, since we have found out the length of AB as 4.092 meter, so half of that, AC and BC, will be equal. So that is 4.092 over 2, that is 2.046 meter. Now, let me then again explain you. Now, I just explained this angle is equal to this angle alpha, and this alpha is vertically opposite to that. Now, if you drop a perpendicular here, this angle will be 90. And the direction of RB at this point makes a 90 here. With this is 90, of which this much is alpha. So therefore this much is 90 minus alpha. So in triangle EZB, this angle will be alpha because this is 90 minus alpha, this is alpha, then only the sum of the three angles will be 180 degree. Then again let this angle is equal to beta, I will require this. Now, now let me go to the next page. Once we have understood the diagram properly, now angle EBC, look at angle E, B and C, this is 90 degree because this direction of RB is perpendicular to the ladder, so this is 90 degree. So out of 90, if you take out alpha, we are left with this much will be 90 minus alpha, therefore this will be alpha. So that is what I am explaining here. EBC is 90, therefore in triangle BCE, tan alpha your tan alpha here in triangle B, B, C and E, B, C, E, right angled here, tan of alpha will be perpendicular, that is BC over BE. So your tan alpha is BC over BE. So by cross multiplying, we get BE is equal to BC over tan alpha. Tan alpha we have calculated as 63 degree 26 minute 5.82 seconds of arc. I am only considering this much. I am neglecting these smaller parts of the angle. And BC we just also calculated. From B to C is the half of the length of the ladder, which we calculated as 2.046. 2.046. So putting the value of BC and tan alpha, your BF comes out to be 1.023 meter. Now again look at the triangle ABE. Now look at the triangle A, B and E, which is also right angled at B, and let this angle is beta. So your tan beta, so your tan of this angle beta in the triangle ABE will be perpendicular over base, that is equal to BE over AB. So tan beta is equal to BE over AB. BE is found out, AB is found out, so beta is equal to tan inverse of this, that comes out to be 14.036243 degree. If you convert to minutes and seconds of arc, this comes out to be 14 degree 2 minute 10.48 seconds of arc beta. Now let us draw the free body diagram at this point, right? At point E. At point E, you can shift RA. You can shift this RA parallel to itself, and show it at point E pointing in this direction. And at point E, this RB is pointing in this direction. And at point E, the weight W at point E is pointing downward. So that is what I am explaining in the free body diagram. So in the free body diagram, RA makes alpha plus beta with horizontal at E, RB makes angle alpha with vertical at E. So this is your point E. X-axis, Y-axis, RA, RB. So now it is simple. Let us then apply sigma x is equal to 0. Means x component of RB will be from this point to this point. How much will be that? That will be RB sin alpha. X component of RA, if you drop a perpendicular from here, will be from here to here. And if their magnitudes are equal, they will cancel because they are already opposite. So RA times this angle is alpha plus beta. RA times cos alpha plus beta is equal to this much. RB times sin alpha, because this is same thing as this in front of the angle. So RA comes out to be, by making side chains, comes to the right hand side. Alpha beta are already found out. So RA is equal to, put the value of alpha, put the value of alpha beta, then this value. This value comes out to be 4.123 times RB. Now this value comes out to be this much. Now then apply sigma y is equal to 0. Now what will be sigma y? This W is already along negative y-axis. The y component of RA will be from this point to this point. And how much will be that? So that will be equal to RA times sin alpha plus beta. And the y component of RB will be from this point to this point. That will be RB cos alpha. So RB cos alpha, RA Sine alpha plus beta are in the positive y-axis, so they will be added and that will be opposed by w. And since the system is in equilibrium, so they have to cancel each other's effect. So that is what I am doing it here. Sigma y is equal to 0. So this plus this is equal to w. Now, RA we just calculated. That was this much. Sine alpha plus beta plus RB cos alpha is 890 Newton, the total weight. That is the weight of the man and the ladder, vertically downward, put together. So if you take RB common, this term has RB, this term has RB. If you take common, we are left with 4.123 sine alpha plus beta plus cos alpha. Now alpha beta is already calculated. So this term, if you take to the right hand side, it will be divided, and just in one set put this thing in a scientific calculator. Alpha beta known, this comes out to be 199.0146 Newton. So now since RB is known and RA we had calculated as 4.123 RB. So if you put it here, the value of RB, here, put RA was this much, put the value of RB, this one, multiply, this comes out to be 820.53 Newton. It's very interesting, and you are likely to get in competitive exams like your JEE Advance, but not in GATE, because if you are applying for civil service and there are lengthy questions to be answered, 5 marks, 10 marks, then such a lengthy question can be asked. So thank you.